Okay, so in this one right here, in the figure below, the circled centered at B is internally tangent to the circled centered at A, which is right here. All right, that point, that's what it means. All right, that's important. The smaller circle passes through the center, right there, so that the center to center is 5 of the larger circle, and the length of AB is 5 units. If the smaller circle is cut out of a larger circle, so basically we're saying if we cut it out of the larger circle and we're left with like this classic moon-looking shape, how much of the area in square units of the larger circle will remain? All right, so what we're going to do first is just find the area of this big circle. All right, so first we need to recall that area. I'm going to write A sub A because we're finding the area of circle A is pi r squared. All right, that's the formula for area of a circle. And then since the smaller radius is 5, that means to get the bigger radius, we're just going to double it. How do we know that? It's based on all that information from above. All right, so it's going to equal pi 10 squared. All right, the radius is 10 of the big circle, so that's why we plugged it in, and we get 100 pi. Similar things will happen for this little circle. This time we just have to focus on the radius for circle B. Still pi r squared, plug in 5, and it's going to be 25 pi. And then just define, I guess what we'll say shaded region would be 100 pi minus 25 pi. All right, because we're just taking that out, and it's left with 75 pi. All right. This next one, the diameter of a circle is 12 meters. All right, so we have some circle. Let's just go ahead and draw that. The diameter of this circle is 12. All right. Point P is on the same plane as the circle and is 6 meters from the center of the circle. All right, which best describes the location of point P? Well, if it's 6, that means that right there, boom, it's essentially a radius length away. It doesn't matter where you put it. You could put it there, you could put it there, you could even put it right here, so on and so forth. It's always going to be on the circle. All right, point P must be on the circle, so its answer is A right there. And then the last one is to estimate the area of a circle. Henry divides the circle radius into n triangles. All right, so what does this mean right here is that this is a radius, and all these triangles here, boom, 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 boom. All right, it's arbitrary. It's n. This means number of triangles. All right, so we could be specific about it, but they're just being general. It's just some amount of triangles we put inside the circle. All right, as shown, and uses the expression h divided by 2 equals base of 1 plus base of 2 dot 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 base of n to estimate the area of the circle. All right, so really that just is saying, well, the area of a triangle is height times base divided by 2. All right, and since we have all these triangles, we just have a number of triangles. Well, it's really just going to be the sum of them all. All right, we have a base plus another base plus another base plus another base, oops, dot 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 plus. All right, it's just saying that this is going to count for that triangle, that triangle, that triangle, that triangle, that triangle, dot dot dot, and it's going to roughly, they're saying the area of all the triangles combined is going to equal the area of the circle. That's what they're getting after. All right, so is this true? The answer is absolutely yes. And why is that? Well, if you look at it, the smaller, so if we make a slightly larger triangle, all right, focus on this one. Notice that this is the height of the triangle, and then we have this gap between the height and the radius. But if I make it smaller over here, notice how the height and radius have a smaller gap, and then even right here. All right, the more triangles I get, more triangles, the closer the height gets to the radius. All right. So his claim is accurate because as n gets larger, the value of h gets closer to the value of r, and all the bases will add up to approximately 2 pi r, or the circumference. All right. And that's that.